My name is Ash Biswai from class 8, and today we'll be talking about chapter 14 of our science textbook, Chemical Effects of Electric Current. Let's get started. So, there's some important words or terms that we have to remember for chemical. This chapter is conductors, insulators, and testers. Last year we had a chapter called the physical effects of electric current, in which we discussed the heating effect and the magnetic effect of electric current. Today we'll be continuing that, and we will be learning about chemical effects. So first, what are conductors? Conductors are any material which conduct electricity through it. Insulators are materials which do not conduct material electricity from it. And testers are instruments which are used to check if current is passing through it in an electric circuit. Like, if we know that this is battery, here there's a bulb, and here there's a switch, and then here we have a material. So this is a circuit, and this material that we're testing is called a tester. This material can be either conductor and insulator. If it's a conductor, the bulb will glow. If not, the bulb will not glow. So that is a tester. Now let's move forward and see what are the uses of LED. So first we recap about the chemical effect and the heating effect. So when we know that a bulb has a filament in it, filament, because of this filament the bulb glows. So filament is made of tungsten, a material which is an insulator and resists the flow of electricity, and that's the reason why, because of the high resistance, a heating effect is produced. But the electric charge, the current which is passing to the filament, should be high enough to heat the filament and glow the bulb. If there's a very small amount of charge, so for filament to glow we need high current, high volts of current. But if, for example, if there's a less amount, amount which cannot glow the filament, then the bulb doesn't glow. This doesn't mean that the material, the tester, is ineffective. Now, for example, we have lemon juice. Maybe the lemon juice lemon juice is a conducting electrolyte, but the problem is that maybe it can have a very less amount of current. It can pass only a less amount of current, and this current cannot glow a LED, a normal bulb. For this we need LED. LED stands for light emitting emitting diode. Okay, so the reason why you use LED is that the electrolyte can pass, when they pass very less amount of electric current, which is not enough to heat the filament and glow the bulb, then we use LED, because LED lights up even when a very small amount of charge is passed. Okay, now we'll move forward and see the magnetic effect of current. Okay, now we'll be talking about the magnetic effect of electric current. We have learned about electromagnets. When electricity is passed through any material, it acts as a magnet for a temporary period of time. For example, if we pass it through a piece of iron bar, then it starts to act like a magnet, having a north pole and a south pole. It acts like it is a magnetic, but it's electromagnet, which means it acts as a magnet for a short period of time. So how do we use this? Okay, we take a circuit. There is liquid in it, something like, again, lime juice we will take, and here we have a compass and a direction compass. So when we do this, electricity passes. Electricity passes from this way or this way, depending on the positive and negative terminal. So when electricity passes, it deflects this. We know this is north, east, west, south. So because of the passage of electric current, the compass needle gets deflected. it gets deflected. So this is the magnetic effect of current. Because the electricity has a magnetic effect of current, it deflects the compass needle to some other direction instead of its conventional direction. This is the usage of magnetic effect of current. Now we will be seeing how chemical effects of current are. So till now we have only seen and learned when electricity passes through a solid. When it passes through a solid, the extra electron present in it, conducts or does the process of electric current. So in an atom, the extra electron that's outside does the process of electric current. But in liquids it is the ions. The ions are the reason for electric conduction in liquids. That's why we say when salts or any type of mineral is present in liquid, it is a conductor. Because normally salts are examples of ionic compounds. Now we'll move forward and see what are ions. In some natural phenomena chapter, we have learned how a material gets a positive and a negative charge. That's the same thing with ions. So the most common ionic compound or a material formed from ions is NaCl. So NaCl, this is the diagram of Na. It has totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 1. It has 11 electrons. And here, this has 17 electrons. So here we can see, actually this is a higher order thing, but for better understanding this is very important. For the stability of for an atom, for stability means so that it doesn't become radioactive or it's stable, the shells, that is this is called shells. The shells should have 8 electrons. As you can see, this has 8 electrons and even this has 8 electrons, but here in the last one this only has 1, and here we can see that there are 7. 1, 2, 3, 4, 5, 6, 7 electrons. So chlorine needs 1 extra electron to become 8, and sodium needs this 1 electron to go away so that this one has 8 electrons. Do you understand? This means sodium can lose 1 electron. Sodium is a metal, and chlorine is a non-metal. So metals can lose 1 electron because they only have 1 electron in the outermost shell. If they lose that, then the innermost shell has 8 electrons. So it can become balanced and stable. And in non-metal, chlorine only needs 1 extra electron. If it gets that 1 extra electron, it becomes 8. So this means both of the atoms have 8 electrons. So this means that Na becomes positive because it loses 1 electron. It has an extra proton. It is as we know that if an object loses electron, it becomes positive, and chlorine becomes negative because it has a extra electron. We know that electron have negative charges, so that means if Na loses an electron, it is not negative, it's a positive, and Cl gets an extra an electron, that means it becomes negative. Now these are ions, and that's why this NaCl is salt. So that's why we say whenever salt is present in any type of water, any liquid, that is a conducting material. So NaCl has a positive ion and a negative ion, and this positive ion is called cation, Cation, and this negative is called anion. So there are two types of ions, cation and anion, which combine to form a compound, NaCl. So how do we understand that? So the main understanding is that metals readily lose 1 electron. They are ready to lose 1 electron because when they lose 1 electron, they become stable. And non-metals readily gain electron because when they gain an electron, they become stable. So for becoming stable, one atom loses an electron and another atom gains an electron. In this way, they are compound and they are ionic compounds. And there are two types of ions, the cation and an anion. The positive is cation and negative is anion. Now we go on to see what are electrodes and how does electrolysis happens. This is a normal setup for electrolysis. So before we start, we have to know what is electrolysis. What does electrolysis mean? Electrolysis means whenever electricity passes through an electrolyte. Electrolyte means any conducting liquid. So this liquid we can see here, this liquid. This liquid is a conducting liquid, so we call it electrolyte. So whenever electricity passes through an electrolyte liquid, then the the liquid breaks into ions. So what we have seen, we learned ions. Why ions? Because liquids conduct through ions, and that's why whenever a liquid is called electrolyte, it means when electricity passes, it becomes ions. It breaks into ions and it goes into two terminals, the cathode and the anode. These two are called electrodes. So electrolysis means the breaking of any liquid into ions when electricity passes. Here, electricity passes through the negative and the positive terminal, and the it passes through two conducting materials. These two conducting materials are called electrodes. The conducting material which is connected to the negative terminal, this is the negative terminal, is called cathode, and the material, the conducting material which is connected to positive terminal, this one, is called anode. So whenever electricity passes through this liquid, the liquid breaks down into ions, and the positive ion, that is cathode, goes to the negative terminal, because we learned that unlike charges attract each other. So that means the positive ion gets attracted to the negative electrode, that is cathode. The cation is attracted towards cathode, and the negative ion, which is the anion, negative ion goes towards the positive terminal, which is anion goes to anode. Now we will take a quick example of what happens when electricity passes through H2O, water. So this is the setup. Electricity passes to H2O water through two electrodes, anode and cathode. Then H2O breaks down into H plus ions and OH minus ions. H plus is the cation and OH minus is anion. So as we have learned, the positive ion, that is cation, will go to the negative terminal. So H plus will go to the negative side, the negative terminal, and OH minus will go to the positive terminal. And that's why whenever you see, whenever electricity passes through water, you will see that hydrogen gas is evolved in the negative side of the terminal. This was how electrolysis was first found. So when electricity passes through the electrodes to water, water breaks down into H plus ion, that's the cation, and OH minus, that's anion. The positive ion goes to the negative terminal, cathode, and the negative ion goes to the positive terminal, anode. And that is how these gases are liberated during the process of electrolysis. So, which liquids have the ability to conduct electricity? Acids, bases, and any liquid with salts can conduct electricity. Acids, bases, and liquids with salts have have the ability to conduct electricity. Now take distilled water. Distilled water, as we know, we have learned that distilled water doesn't have any minerals in it. It is just pure H2O. And without, as there is no mineral or any salt present in it, it is a poor conductor of electricity. It cannot conduct electricity. But when you add salt with it, it becomes salt solution. And as we know, salt can conduct electricity. So this is how distilled water turns to be a conductive. So when distilled water is mixed with salt, it has the ability to conduct electricity. Now we'll go forward and see electroplating. We have learned that some material, when exposed to air and moisture, rust. For example, iron. That's why many material which are made from iron are coated with other materials. Like for take iron nails. Iron nails rust, and after rusting, their value decreases, and mostly they are not used. But when they are galvanized, that means they're coated with zinc. When zinc is coated on iron nails, the it becomes galvanized irons, galvanized iron nails. And this is how iron nails don't rust, because zinc is non-corrosive. It does not corrode and does not rust. So that means you have a nail, and that nail is coated. It's made of iron, but it's coated with zinc, and zinc forms a protective layer on it and covers it. So zinc becomes a barrier between iron and the moisture present in the air, and this is how the material don't rust. So when a thing is made from an iron, from any material, and they have certain lack in some of the physical properties, like how is of iron, how it rusts and corrodes, it is coated with some other type of material which has better and more important physical properties. For example, we have chromium, gold, silver, chromium, gold, silver, tin. Then you also have zinc, as we told. These are some of the most commonly used minerals that are coated on other items. For example, we take iron cans. The canned items, the canned food. We have seen that food is canned inside cans and are sold to us. They are actually made of iron, but iron reacts with the food. It can react with the food, or it also rusts to the air present in it. And after rusting, the food gets spoiled inside it. So that's why iron cans are coated with tin. That's what we call tin cans, because tin does not corrode and is cheap. Then we have seen the handles of bicycles. When you scratch the handles of the bicycle, you see that the inside part of it is not lustrous. It is not beautiful. It's very dull. That is iron. The handle is made from iron, but it's coated with chromium, because chromium has a shiny and good appearance, and it does not corrode. So we take items which have very good physical properties that should be coated on other items. But chromium is very expensive. These elements that we see are very expensive. That's why we don't directly make items from these. We make items mainly of iron or other elements, and then we coat it with other minerals. We'll be seeing how. This is the basic setup for a process of electroplating. What do we have here? We have the circuit with the battery. The positive terminal has an anode. The negative terminal has a cathode. Then we have this is called the purification of copper. Like when we have an impure copper rod, how to change it into a pure copper rod. So in this process, first, electricity is passed. This material is CuSO4, copper sulfate. Copper sulfate, when electricity passes, dissociates or splits into ions. This is copper ion. This is SO4 ion. So As we know, copper being positive goes to the negative terminal, and this is the negative terminal cathode. So copper gets deposited onto this. Copper gets deposited, and then here only SO4 is left, because here the copper is gone. Only SO4 is left. Now SO4 cannot escape because there is something over here, and this is also copper. So copper from this rod comes to the liquid, and then again becomes CuSO4. Again, some amount of copper goes to this plate. Again, some amount of copper comes back, and again copper goes, and again copper gets deposited. So this process will continue till this material you see has no copper left, and whatever impurities will be there will be at the corner. This is called anode mud. So this process is called copper refinery or purification of copper. In this, we have an impure copper rod. We have to attach that impure copper rod to the anode, the positive terminal. Then we have to put a plate attached to the cathode, the negative terminal, and we should have a liquid of copper. Because we want copper purification, we want copper to be deposited over here. This liquid has to be copper, has to be a compound of copper. That's why we did copper sulfate, CuSO4. So the process is that electricity passes to copper sulfate. Copper sulfate breaks into CuSO4, C2 plus and SO4 2 minus. That means ions. This is the cation, this is the anion. The cation, that's the metal copper, goes to the cathode, the negative terminal, and gets deposited on this plate. So SO4 here. Now there is no copper left in the liquid. Only SO4 is there. So some copper from this rod goes to the liquid. Again, the liquid has copper sulfate, copper. Again, the copper will go to the plate. Again, as the liquid becomes copper, there's no copper left in the liquid. Again, some copper will come from the rod to the liquid, and again it will go back to the plate. So basically we can say that copper gets deposited from the positive to the negative terminal. This process will carry on till there is nothing left in the copper rod. So here now we can see that all the copper that is present in the copper rod has gone to the copper plate, and this pure copper plate, and all the dust and impurities that were there has come and settled down of the beaker, and this is called the anode mud. So for this we need an electric circuit, we need a impure copper rod, which is attached to one of the electrode, that is the positive electrode anode, and a copper plate which is connected to the negative terminal cathode, and an electrolytic substance, that is a conducting. This liquid should be conducting, it should conduct electricity and should be a compound of copper. These are the necessary requirements. The process, as we know, it breaks CuSO4, then the positive goes to the negative terminal, gets deposited over here. Some copper from the rod goes back to this liquid, again it goes back here, again it comes, again it goes back. So this process will carry on till all the copper from here goes till here, and there is nothing left over here. So this means the copper from positive goes to the negative terminal, and there is nothing left in the positive terminal now. So here our chapter ends, but now I will be telling you some important the important electroplating things, that, like, for example, we have chromium, we have silver, we have gold, we have tin, etc., which we coat on other substances. I will be telling you some of the physical properties of these and why they are widely used. So here, the most common five coatings. First is chromium. Chromium is highly used in utensils, handles of vehicles, bicycles, then bathtubs, etc. are made from chromium because it is shiny and lustrous. It does not corrode like iron. It does not rust like iron. So these properties make it very useful for coating. But chromium is so it is very cheap. I mean, very expensive. Sorry, chromium is so expensive that that we can't make things fully from chromium. That's it. We make materials from iron and coat it with chromium so that it looks like chromium. Then next, we have seen ornaments. Mostly ornaments after some days of use, you can see that it loses its luster. So in this process, if you see, actually materials, many ornaments are made from other materials, but they're coated with gold and silver so that it looks like they are brand new, made from gold and silver. Why? It is shiny, it does not react at all with any type of material, it is non-corrosive and non-rusting. These items make it very useful. And gold and silver also are very expensive, as we know. Then tin and zinc also have the same properties as this. That's why they are used. But chromium have health issues. Chromium causes respiratory issues, then causes many skin problems, etc. That's why chromium is not used nowadays, except and tin and zinc are used. So these are some of the important materials which are electroplated. And next I will show you an example, another example, an easy example of how electroplating happens. This also has the same type of setup. There are three important things: the cathode, the anode, and the electrolytic substance. Here, this is the positive and this is the negative. Again, we have the coating material on the anode and the item which has to be coated in the negative, on the negative side. So here, there's a spoon made of iron or any material in the negative, and there's a silver rod present in the positive. So we want this spoon to be coated with silver. That's why we have that material in the positive. And here again, a liquid is a compound of silver. AgNO3 means silver nitrate, and that's a compound of silver, and it also is conducting. So again, electricity passes, AgNO3 breaks down, and Ag goes to spoon, it gets coated. Again, silver from this goes to the liquid, again it goes back to the spoon, again it comes, it goes to the spoon, and it happens till there is nothing left in the rod. So this again means that the atoms from the positive go to the negative terminal, and we get a completely coated, silver coated spoon. This is how electroplating happens. Electroplating is the most basic and important use of the chemical effects, that is the electrolysis. Now will summarize what we have learned. We have learned that when electricity passes through solids, it is the free electron which causes the passage of electric current, and when it is in liquid, it is the free ions. The free ions are the reason for the conduction in liquids, and these free ions are salts, and we have seen how ions are formed. One of the common is NaCl. So like that, when we go, we know there are two rods connected to the liquid. That is those are called electrodes. The positive rod is called the anode. The negative is called the cathode. Then as electricity goes to the liquid breaks into two types of ions: cation and anion. Cation is the positive ion, and anion is a negative ion. And as we have learned that unlike charges attract, like that, the positive ion goes to the negative terminal and negative ion goes to the positive terminal. So that's when electricity passes through any liquid, gases are liberated. That means gases are produced. You can see that when electricity goes through water, you will see hydrogen gas being liberated from the negative side, because H plus is a positive ion. And this is how electrolysis happens. We also know what is the use of LED. When the charge is present in an electric circuit, the current present in electric circuit is very less, and it cannot glow the bulb. That means that means you have to use LED, because LED even glows when there's a very little amount of charge present in it. And lastly, we came to electroplating. Electroplating uses the theory of electrolysis, because when electrolysis happens, the liquid is split into ions. And here we have seen that the item that you want to coat is there in a negative, and the item which has to be coated on that other item is there in a positive. For example, here that you want to coat the spoon with silver. The spoon is there in the negative, and the silver rod is there in the positive. And we know how the process happens. The atoms, the liquid breaks up, the positive atom goes to the negative side and gets coated on the spoon. The same type of atom is also present in the rod. So the rod comes, it gets mixed with the liquid, it again becomes AgNO3 for example, and again it goes to the spoon. For like this, the process happens. So basically, the atoms from the positive side goes to the negative side, and this is how electroplating happens. Then we also saw some of the common minerals which are coated like chromium, gold, tin, zinc, etc. And here our chapter finishes. I hope you like this video. Thank you.